All right, here we are, Chapter 8, Section 5, the last section in our sequence and series chapter. And up till now, we've been doing quite a bit of writing rules. And the way we've been writing rules in the first half of the chapter was we wrote explicit rules. So the explicit rules were what we talked about, where we had an arithmetic sequence and we had a sub n equals a sub 1 plus n minus 1 times d. And remembering that we would always have an a sub n and an n in our final answer. And then we also talked about geometric, where you have a sub n equals a sub 1 times r to the n minus 1. And you would always have an a sub n and that was the wrong thing to highlight there, and an n in your answer. Now we're going to look at a recursive rule. And writing a recursive rule just means that recursive means you're looking at what's before you. So recursive means we are going to look at the term previous to the one we want and give a rule on how to get the next term. So today we're going to talk about recursive rules, how to write them, and then how to go between explicit and recursive. Now, as you're listening to this video, it's going to be fairly lengthy, but you have 2 full class periods to get done with the video, the notes, and the homework that goes with it. So the recursive equations for arithmetic and geometric sequences are on our page here. And basically all that it means is that if you have any term that you want, a sub n, you're going to take the term previous to it and add the common difference. Or if it's geometric, you're going to take the previous term and multiply it by the common ratio. With a recursive equation or recursive rule, you have to define a sub 1 every single time so that you know where you're starting, what your first term is, so you know where to go from there. So we have a couple of arithmetic and geometric recursive rules here. Notice it's recursive because it tells us what a sub 1 is, and then it gives us a rule. So what this is telling us is that my first term in my sequence is 1. And then after that, anytime I want to know the next term, I am just going to add 4. So I'm going to do 1, add 4, and I get 5. I add 4, and I get 9. I add 4, 13. I add 4, and I get 17. Add 4, get 21. So this tells me where I start and then where I'm going from there. A sub 1 on the next one is 4, so I know my first term is 4. And from there, I am subtracting 3 each time. So minus 3. 4 minus 3 is 1. Minus 3 is negative 2. Minus 3 is negative 5. Minus 3 is negative 8. Minus 3 is negative 11. And you could keep going on and on and on. And if I ever wanted to know how to find the next term, I could just look at any term that I want. The next term is just going to be minus 3 from there. These bottom 2 are geometric. I have my first term is 1. It tells me my common ratio is 2, so I'm multiplying by 2 each time. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32, and so on. Okay, this one, my first term is 2, so I know my first term in my sequence is 2, and I'm multiplying by negative 3 each time. 2 times negative 3 is negative 6, times negative 3 is positive 18, times negative 3 is negative 54, times negative 3 is 162, times negative 3 is negative 468. And you could go on just by multiplying by that common ratio each time. So the next thing we want to do is if I give you a sequence here and I want you to write a recursive rule. Okay, so remember, recursive rule means you have to define a sub 1, and then you have to know, well, is it arithmetic or geometric? So you need to know, do I need to know what my common difference is, or do I need to know what my common ratio is? And in this case, 3, 13, 23, 33, 43, you're adding 10 each time. Well, if you're adding the same thing each time, it's arithmetic, and your common difference is 10. So our final answer, if we're writing a recursive rule like this, I just say what my first term is. My first term is 3. And then my rule a sub n is I'm going to write it like this. I'm going to say my term previous to that is a sub n minus 1. And then from that previous term, I'm going to add 10. And that's all there is to it. On this one, if we look, all right, we've got 16, 40, 100, 250, 625, and it has a common ratio. It is geometric. Our common ratio, if we divide any of them, let's do an easy one. If I pick 100 divided by 40, we could have done 40 over 16. We could have done 250 over 100. I just tried to pick a nice easy one. They all will simplify to 5 halves. So my common ratio on this geometric sequence is 5 over 2. To write a recursive rule, all we need to know is the first term and our common ratio. Our first term, we know, is 16. And then to write our rule, it's a sub n equals r times a sub n minus 1. And this a sub n minus 1 and a sub n are going to be part of our rule. So a sub n equals 5 halves times a sub n minus 1. That tells me I'm going to take, and that n minus 1 tells me I'm going to take the term previous to it and multiply it by 5 halves. Okay, now I want you to try these two, and when you have the rule written, don't forget to write, to define what a sub 1 is for each of them. Okay, and then what your rule is for each one of them. So you have 2 things that you have to do with a recursive rule each time. And then just check in with me, and then I will let you move on. Okay, so this is just remembering, all right? So we've talked about explicit and recursive rules. If we are talking about explicit rules, again, that's where we started the unit at. We were in arithmetic was, we had a sub n equals a sub 1 plus n minus 1 times d. You've written rules with that, and geometric was a sub n equals a sub 1 times r to the n minus 1. Now we've introduced a recursive rule where you have to define your first term for both of them, and then in this case you're just looking at a term previous. If it's arithmetic, you're adding the next, your common difference, and if you have a geometric, you have your previous term and you are multiplying by your common ratio. So what we're going to work on is going between these 2 rules, going from explicit rule to recursive rule, and from a recursive rule to an explicit rule. So knowing these formulas is going to be very, very helpful. Okay, so I give you an explicit rule. Okay, so I give you a sub n equals negative 6 plus 8n in order, and we are going to write a recursive rule. Okay, remember, in order to write a recursive rule, you have to know what you have to know what your common difference is, and you have to know what your first term is. Now, as it is written here, this is explicit. Okay, so we need to figure out what our common difference is. Our common difference, remember, was when we wrote that rule, we always multiplied n minus 1 times d. So if you remember in that original arithmetic rule, it was a sub n equals a sub 1 plus n minus 1 times d. When we multiplied that common difference times n, the coefficient of n was our common difference. So d, in this case, is going to be the coefficient of n. So in this case, our common difference is 8. Okay, now, just to be clear, the a sub 1, your first term, is not negative 6. Your first term is not negative 6. In order to figure out what your first term is, you have to put 1 in for n. So we're going to say negative 6 plus 8 times 1. That's how we get our first term. Negative 6 plus 8 is 2. So our first term, in this case, is 2. Now we can write our recursive rule. Step 1, define a sub 1. I know a sub 1 is 2. Step 2, I write my rule. Any term can be defined as the term previous to it, a sub n minus 1, plus d. And we said that d is 8. Okay, here's a geometric one. Okay, so we have an explicit rule. Okay, and geometric is always a little bit easier, but we have a geometric rule, or excuse me, we have an explicit rule, and we want to write a recursive rule. Well, anytime we do these, we need to know what our common ratio is and our first term. And the formula for a geometric sequence has that right in there. So our our ratio, our R value here is 1/2. And our first term is -3. In a geometric sequence like this, everything is pretty clearly laid out. It's a little tougher with arithmetic. So when we go to write a recursive rule, step 1, define a sub 1. We said that's -3. And then we write our rule to find the next term. So a sub n, to find any term, we basically take our common ratio, which is 1/2, and multiply it by the term previous, which is a sub n minus 1. Okay, now we're going to go the other way. Now I'm going to give you a recursive rule. So this is a rule that's recursive. I know it's a recursive rule because it defines a sub 1 and it's written in the form a sub n equals a sub n minus 1 plus d. Okay, so it's arithmetic. I know that because there's a common difference that's being added or subtracted to the end of it. And if we look, what is our common difference? Well, our common difference is that number that's being added or subtracted on the end. In this case, our -2 is our common difference. And a sub 1, it tells us, is -5. So now we need to go back and we're going to write that explicit formula. So we have a explicit is a sub n equals a sub 1 plus n minus 1 times d. And we know what d is and we know what a sub n is. So we have a sub n. Our first term is -5. And our common difference is -2. So those are the numbers that we are just going to put in. So we have a sub 1 is -5 plus n minus 1. And our common difference is -2. Okay, and then we just need to combine like terms and multiply and distribute. So we'd have a sub n equals -5 plus, I'm going to distribute, -2n plus 2. And so my rule, my explicit rule, is going to be -2n minus 3. Okay, so this is a geometric sequence because it's being multiplied. And we have an a sub 1, and we have 2 times a sub n minus 1. Easy to find our common ratio. Our common ratio is 2. Again, geometric sequences are way easier. Our a sub 1 is 10. And to write an explicit rule, okay, it's given recursive, we just need to write explicit rule. Remember, it's a sub n equals a sub 1 times r to the n minus 1. So I know my first term is 10 times r to the n minus 1. Oh, excuse me, we know what r is. Sorry, r is 2. I forgot to put the 2 in there. I apologize. So it's 10 times 2 to the n minus 1. And of course, we do not ever multiply our coefficient times our base, so that is not 20 to the n minus 1. Our final answer is just 10 times 2 to the n minus 1. Okay, now I want you to try these two. I want you to go back, think about how this one starts out, okay? Starts out as explicit, and you need to write a recursive rule. Okay, so in order to write a recursive rule, remember you have to define a sub 1, okay, and then you have to write your rule. And on the bottom one, it's geometric. Again, you have to define what a sub 1 is, and then you have to write your rule. Okay, so you're going to write a recursive rule given the explicit rule. And then on this one, you're going the opposite direction. This time, it's given as recursive, and you need to write the explicit. Okay, so you're going to be going the other way. You're going to have to write the explicit rule. And remember, explicit is a sub n equals a sub 1 plus n minus 1 times d. And your explicit rule for geometric is a sub n equals a sub 1 times r to the n minus 1. Just kind of helping you to remember where those go. And then, since this is a 2-day assignment, you can finish the video, you can do all the notes, you can check the problems with me, the you try slides with me, and then there is a 8.5 practice a worksheet that is in Schoology that you need to submit into that homework assignment, please.